Hello everyone. So today we are going to cover the problem linked list cycle. So the input given is a head of a linked list and we are going to return whether the linked list is having a cycle or not. So consider the example 1. It starts with this node 3 and we have a cycle from the node -4 to 2. In this case it has to return true because there exists a cycle. Moving on to our second example, this is again having a cycle, so we have to return true. In third example, there is only one node and there is no cycle or other nodes exist in this linked list. So in this case, the output is false. So how are we going to approach this algorithm? So the method 1 is consider we are having a marker that marks every node we visit. So starting from this, we are just marking every node we visit, and if we come across a node that is already visited, so in this case we can determine this has a cycle. This is nothing but consider a car is going in a track. It travels all the way through the path, and if it get to loop again to the same path, then we can easily find there exists a cycle. So this example or this method is efficient only if we can modify the linked list. If we can't, then it cannot be applicable to this problem. So what is going to be our next approach? Consider there exists a path which has cycles. So consider two animals traveling in two different speeds or two cars traveling in two different speeds. Eventually, when as they move along the path, as one moves faster and other moves slower, they eventually gonna collide at some point, and that is where we get to know there exists a cycle. Using the same technique, we are going to approach this algorithm using two pointers. The pointer 1 is going to be fast and pointer 2 is going to be slow. So now our pointer fast move by two nodes and pointer slow going to move by one node. So as one pointer moves faster and other one moves slower, eventually they get to collide at some point where the linked list creates cycle. So if we couldn't make the both pointers meet at some point, which means we don't have a cycle exist in our linked list. So let's have a dry run with an example. This is our example given. We are going to start our pointer fast and slow here at head of the node. When slow moved by one point and fast moved two nodes ahead. Further moving slow by one step, slow is on the node 0 and fast moved to -4 and then to 2. Finally, both the pointers met at node -4, which means there exists a cycle. So let's code this. As we have saw examples already, directly dive into coding. I am starting the algorithm by declaring two variables or pointers, that is my pointer fast and pointer slow, which points us at the head of the linked list. So now our algorithm going to loop through the linked list till they meet null. They are going to iterate fast is equal to fast.next as it is going to move two steps ahead, and slow is equal to slow.next as it moves one step. And inside we are going to check if fast and slow collide each other and return true. If not, return false. Let's include the basic condition that straight away if head is equal to null or head.next is equal to null, then there exists no cycle. So directly we can return false. Thanks for watching the video, and this algorithm runs at order of n time, where n is the size of the linked list. So thanks for watching.